Okay, we're going to look at calculating z-scores again here. There's a little chart that gives us our info. We know 68 is within one standard deviation of the mean. 95% of the area under the curve or the percent information is within 2. And 99.7% of the area or information was within 3 standard deviations of our mean. So our formula says the z-score is equal to data minus the mean over the standard deviation, and that's what all of these stand for here. So minor league batting averages are normally distributed and have a mean of 250 with a standard deviation of 0.5. Okay, let's find the probability. Okay. Probability that our data is, let's say, less than, I don't know, 100 or 0.125. Okay, 0.125. So we'll quickly make our chart here. Okay, I'll do my best to make our standard deviation. That was all right. It's the middle, so here's like 1 deviation. I'm very good at this. There we go. It just has to be a rough sketch. We're just trying to write some numbers down so that we have an idea of what the heck is going on. So our middle one here, we already said the mean was 250, right? So if a standard deviation is 0.05, we would add 0.05 and then add 0.05 again. I'm sorry, 0.05 and plus 0.05 again. So this value being 300, 350, 400 in terms of batting. Does that make sense how we got those values? Okay. And then the other way, we would subtract 0.05, subtract 0.05, and subtract 0.05 in order to figure out, at least these are our key points where the standard deviations cut off. So this is 200, 150, and batting 100 in baseball. Okay, we already said our percentages and all of that stuff. So we're looking for something that would be less than 0.125. So 125 looks like it falls directly in between 100 and 150. That's what 0.125 would be. And it is asking, let's get a colored line here. It's asking for the information that is, or the probability that you are batting less than that. So you'll be batting worse than that. So that's that little tail end of the curve. Okay. Well, we already know the middle is 50% of the area. Remember, the area under the curve is technically equal to 1. Okay. So if we're going to the right, that's 50%. If we're going to the left, that's 50%. This is clearly less than 50%. Okay. So we'll plug in our info, plug in the z-score, and then try to make sense of it. So the z-score was equal to our data. Our data is 0.125. Subtract the mean. The mean was 0.250. And all over the standard deviation, which is 0.05. Are you okay with that? Okay. So the z-score is equal to 0.125 subtract 0.250 equals, okay, and then that number divided by 0.05. Negative 2.5. Negative 2.5. Okay, so let's get our z-score table. And lo and behold, my z-score table doesn't have any negatives. So what the heck does that mean? Well, remember I talked about this before. This z-score table only does half the z-score table, right? Hence why it only almost goes up to 50%. So we take the absolute value of the number and we use that to find our percentage. So ours was, what was it again? Negative 2.5? Negative 2.5. So we're looking for 2.5. So we look down our list and there we go. 2.5, and luckily it doesn't extend any further. So we're looking for this number here. It's hard to see. It says 0.4938. Okay, 0.4938. So I'm going to write that down. When we convert it, we got 0.4938, and you can think of that as like 49.38%. That's what the percentage. Okay, so let's think about this for a second. Do you think that's what this means? That 49% of the people have a batting average of less than 1.25? No, because 49% would be a number like right here, really close to the middle, since the middle is 50. Okay, so what they actually did, that found the area of the curve from the middle to where we want to be. Okay, so that's what this is. So they've just found the 0.4938. 0.4938 represents everything in yellow. And technically, all the way to here is represented by 0.5000. You could write many zeros, but in other words, half. Excuse me. So, in order to find this little tail here, we got to take this number, and then we got to cut all of this off, which is that number there, 0.4938. So we take 0.5, okay, and we're going to subtract 0.4938 from it. And that's going to tell us what was left at the end. Excuse me. So we get our calculator, 0.5, subtract 0.4938, 0.0062. 0.0062. And remember, I told you these can be multiplied by 100 to find percentages.
Yeah.
So I multiply by 100, and that would actually equal a percentage of 0.62%. That's what that percentage would be. The likelihood that you bat less than this is 0.62%, not even a full percentage. Seems really odd, but let's use our these pillars of standard deviation. Let's use them. Remember, this is 50%. Okay, so we know that at least 50% is above this. Okay, and because all of this is 64, you divide it by 2. No, sorry, 68 divided by 2. This is 34%. This is 34%. Because all of this is 95, we subtract the 68, we got 27 last time we did that. So that means that this sliver is 13.5, is that what you said?
Yeah.
Okay, and this sliver here is 13.5. Okay. So using the reverse information, I know this seems a lot. We know that's 50% plus 34. Okay, so we'll kind of write that out. So we have our 50% plus our 34. Plus our 13.5, this is all to the right of that blue line, right? 13.5%. So already we're looking at 97.5% of the information is above this bar. Okay, well, that makes sense. That only leaves us with like 2.5%. And then it's obvious that this sliver is greater than this sliver, so there's over more than half of whatever would be left here. So technically, since this is 99.7, right, this thing here, we're just a little bit greater than whatever's left of that. If 99.7 is between those, we can technically find that sliver too. This is how we'd find it. We take the 95 between the two other pillars, and we'd subtract our 99.7% from the 95. Okay, this idea, I know this is a little foreign here, but that's going to give us 74%, and then we divide that by 2. You're looking at 2.35. So this is another. This part here is another 2.35%. Okay. So we know we're a little bigger than that. If we were to add 2.39% to this, so 97.5 plus another 2.35%, that means you're at 99.85%. So to the left of this bar is 99.85% of all the information. So our 0.62% doesn't seem that odd anymore. That actually makes sense. That's how much area is here. Though I didn't draw it to scale, that's actually how much there is. And I know the end part is kind of confusing, but if you just focus on subtracting this from that whole value, you can find it. And you don't need to use all that. All that other stuff was just to help us kind of make sense of such a very, very tiny number.